Anecdotes?
Yeah,
As
okay.
opposed to a specific machine?
Why don't you do that? Give us, 10 minutes, and we'll call it quits for the day, because then we'll all learn something.
Okay. Seymour Cray from the class of 1950. And like many people graduating in 1950, he was considerably more mature.
Hey, if not, there was nothing.
Is it on?
Yeah, go ahead.
Hi, I'm John Greene. Today is first Saturday in August of 2002. And I'd like to speak a few minutes about Seymour Cray. Seymour Cray graduated in the class of 1950. And like many people who graduated that year, he was more mature than most college seniors would be, in that he was a World War II veteran. So he then went to work in Minnesota, where he had gone to college, at the Engineering Research Associates, one of the very early pioneers of computers. They had done contract work for military agencies of various types during World War II and continued that work after the war ended. So the first computer he worked on was called the 1103. It was one of the very early tube computers built for scientific calculations. And as he describes it himself, the first 5 or 7 years of his career, he basically was learning the tools of the trade and copying other people's work and whatever. So he really doesn't claim any unique inventions in the early 50s. But he came to the attention of the founders of ERA very quickly because it was such a small company. So when Bill Norris split off, oh, actually, I should mention that ERA got bought by Remington Rand very early. They bought the Eckert & Malkley Computer Company out of Pennsylvania, merged it into themselves. They bought the Engineering Research Associates out of Minnesota, merged those two companies together into a Univac division, which was named not after an ERA computer, but after one of Eckert & Malkley's computers called the Univac. So he stayed at Univac for just a short time after the company after ERA was purchased. Then in 1957, when Bill Norris founded Control Data Corporation, also of Minneapolis, Seymour Cray was invited to be a founder, and in fact he was the principal designer. So in order to get some cash flow going, they designed a quick computer very quickly called the Model 160A. It took a very short period of time to design it, and then get it into production so they could get some cash flow. At that point, Seymour used his position at Control Data to do what he really wanted to do with his life, which was design the fastest scientific computers that are available at a profit. So he moved back to his hometown of Chippewa Falls, Wisconsin, a couple-hour drive away from Minneapolis, and founded a research lab where he would design high-performance computers. So Control Data was founded in '57, and it was approximately 1960 when he founded this sort of Skunk Works project on the lines of the Lockheed Skunk Works in Kelly Johnson. That is a very small team of people with a very clear goal, with very little interference from anyone not on the project, could accomplish something of extraordinary in very short periods of time. So in 1960, the world's fastest computer for scientific calculations was the Lark, built by Univac, and it was a 60-bit computer. So his Control Data 6600, the first of his fast computers, copying that aspect of Lark, he made it a 60-bit computer. And about a year into the project, they found that they had made a very serious mistake, that one of the people on the project was a turkey. It was the guy responsible for cooling the machine. So about a year into it, he found out that he'd have to start over on how to cool it. He had the good sense to throw the entire design out, because with the cooling being a year late, the whole machine was going to be a year late. And if you didn't redesign your machine, it would simply be no faster than it would have been had this guy not been a turkey. So he threw the design out and doubled the performance goal for the machine. So then it was finally announced. In the case of that class of machine, the announcement is kind of like anticlimactical, because every potential customer has already been given a private, advanced description of the machine. So it formally got announced in 1963, summer of 63. But everyone who might ever buy one of these things already knew about it. So it got shipped it announced in 63, shipped in 64, and paid for in 65, which is not unusual for that class of machine. Because he had doubled his performance goal, one thing about this machine that was unique was not only was it the world's fastest computer on the day it was announced, but it was still the world's fastest computer 5 years later, the day before its compatible successor was announced. So the compatible successor announced or shipped in 69 was the CDC 7600. It was not so extraordinary. So it, in fact, was not the world's fastest computer 5 years after that. And it was very rare for any computer ever to be the world's fastest for 5 years. There's a lot of anecdotes about Seymour Cray. One of them is his famous quote that parity is for farmers. His early computers had no parity. His object was to build the fastest computer possible. He felt that calculating parity and checking it before you produce the result would slow the machine down. So instead he used good design that simply didn't get parity errors. Eventually that didn't work. So the 6600 had a relatively small memory and no parity. The 7600 had a somewhat larger memory but no parity. Then he started designing a 8600 computer for control data that was to be a 4-processor machine. Unfortunately, 2 years into the project, Control Data decided to get out of the large computer business. But he still had a very close working relationship with Bill Norris, so he was allowed to leave the company, which got a large share of stock in his new company, in a very friendly way. Basically took his entire Chippewa Falls team to a new company he founded called Cray Research. So it had taken him about 5 years to design the 6600, about 5 years to design the 7600. 2 years were spent on the 8600 that was unable to be used by his new company, even though they left on friendly terms, because the assumption was that that machine would be built by Control Data with all of their infrastructure. Now he's suddenly working for a startup company, so it's impractical to build the machine that he had started designing. So when he built his Cray 1, it was built an entirely different concept. Instead of a lot of discrete components, it had a lot of integrated circuits. Also, it had a much, much larger memory. Instead of like 64,000 60-bit words, this one had 1,000,000 64-bit words. So he designed his first prototype with a quarter of the maximum memory, 250,000 words, and no parity. And he couldn't find a customer for it. It never did get sold. Every customer demanded error correction, which was quite common in those days. So he had single-bit error correcting, double-bit error detecting memory as an add-on. And it turns out that the effect of this was that the access time to a first word of memory coming streaming out, from the time you ask for the word to the time you've got it, which was going to be 9 clock cycles without parity, suddenly became 13 clock cycles when you added the ECC on it. For most computers, that would have just killed the entire machine. You would have just scrapped the design. But this machine was a vector machine and was designed to treat main memory as a peripheral, as a slow access peripheral. So you tended to ask for a word out of main memory long before you really needed it. So you do ask, and then calculate, so that there'd be a long delay from when you ask for a memory till you really used it. So the change from 9 cycles to 13 cycles didn't kill the machine.